Hello and welcome back to Getting Started with Machine Learning with Python. So we're starting a new section about preparing your datasets for machine learning with data cleaning. So overall, in the last section, we understood some fundamental concepts in machine learning. And one of the main takeaways is machine learning has three ingredients. There is the data, there's the model, and there is the feedback mechanism. So in this section, we're going to start with the first ingredient, which is the data. And arguably, I think this is the most important ingredient in your whole machine learning pipeline. Without data, there's no machine learning to be done. I'm going to introduce data cleaning, which is the process of taking data from where it's generated and preparing it so that it's ready for machine learning. I'm going to talk about data cleaning in 4 parts. Number 1, how we can fix our machine learning models and create a good foundation of a machine learning work by understanding our data source. Number 2 is I'm going to talk about how we can deal with missing values using an example. Number 3, I'm going to talk about the procedures of standardization and normalization for us to deal with variables with different scales. And then in the last video of this section, I'm going to talk about how we can eliminate duplicate entries. This video is about fixing our machine learning models by understanding our data source. I say fix. By fix, I mean if your machine learning algorithms aren't performing that well when we start exploring those topics in the course, one of the best ways is to understand deeper what your data is doing, where do you get your data, how was your data generated, to make better and more informed decisions around your features and the models you're applying to, whether your models are accurately modeling the effects in the data. In this video, we're going to take a look at number 1, the importance of data, number 2, what to look out for in your data, and number 3, using the Boston house price example to show you how we can understand data better. So, importance of data is very easy. As I said, without data, there's no machine learning. All machine learning is based on data and a lot of computation. So to look out for in our data, the first thing to do is to understand how the data is collected and how it was processed. So in scikit-learn, you can very easily load this toy dataset called Boston house prices, where you get attributes of a house and you can predict its house value. So let's use this example to take a look at what to look at in data. So I have opened my Jupyter notebook, and as usual, you can find these notebooks in the company code files from the course. So the first thing we're going to do is I've already installed scikit-learn from last section, and we're going to import this load Boston function from the datasets submodule of scikit-learn, and then we're going to invoke load Bostons as a function and capture the returning data from this function into the variable called Boston house prices data. So nice and easy. So we've loaded this here. So the thing that I want to impress upon you is we always need to understand how the data is collected and where the data comes from. So most datasets have a README file, and in particular, all the toy datasets within scikit-learn have a property called DESC. So let's take a look at that. You need to print this, I believe. Okay, so the first thing we want to understand is how big is the dataset. So in Boston house prices data, there are 500 data points, so not a lot, but enough. There's no really rule of thumb around how big your dataset should be. One of the examples is, according to the ImageNet dataset, you should have 1,000 examples per class if you want to do some very complicated classification. But other than that rule of thumb, I've never heard about a sensible rule of thumb around how big your dataset should be. So here in the Boston house prices datasets, there are 500 data points. And the next thing to look at is how many attributes are there, right? So there are 13 numerical or categorical attributes. And then the median value, which is the median value of the house price, is the target, right? So attribute 14. So recall that in the first section, I talked about how machine learning is basically modeling reality with a simplified formula. So we can look at each attribute's information and think about how that might affect our target, right? So the first thing to do is to understand what the target is. So the target is the median value of owner-occupied homes in thousands. So the first thing you should know is, like, if the median value is 50, then it's a 50,000. The median value of owner-occupied home in that region is $50,000. And you should also think about, like, where and when this data set was collected. So I think this is from the 80s, so very old data sets. So you need to, like, keep in mind about how things worked back then. So one of the examples is, for example, average number of rooms per dwelling. That's quite straightforwardly proportional to the median value, right? You can expect the more rooms there are, the higher the median value should be, right? Or we can say the per capita crime rate. If the crime rate is high, the value of the own home should be lower. Some things are less straightforward. So, for example, index of accessibility to radio highways, right? Or weighted distances to 5 Boston employment centers. Those are less straightforwardly saying, oh, if there's more accessibility, it should be higher priced. But you also need to think, okay, if it's very close, then it should surely impact the noise level of the property and therefore impact the value of the property, right? So this is what I mean by when we understand where our data is from, when is it from, and how is it collected. So that when we start running models over this, and bear in mind that according to our framework, this is a supervised learning task because we have examples of the median value supervising us to learn how to combine these factors to learn the median value. And it's a regression task because we are predicting a number, which is a median value. And that's all there is to it. So I wanted to really bring home the point that without good data, there is no machine learning. And to look out for things and special characteristics in your data, you should always look at how it is collected. There's usually a README file or what is called data dictionary that allows you to understand what attributes you're playing with or what's the inputs. So, for example, in the Boston house prices example, we saw 13 different inputs ranging from number of rooms to accessibility into radio highways. And then we had one target in the supervised regression task where the target is the median value of owner-occupied homes in thousands, right? So understanding how the 13 inputs are collected and what they are would then give you an insight on, maybe the guys will build a linear model for the room size and the area and its accessibility to city centers, but then we'll build non-linear models to things like noise level and education in the neighborhood.